Okay, Bismillah ar-Rahman ar-Rahim. So this is our last topic of Chem 100, and today I will teach you about some of the organic compounds, and there are a lot of variety of the organic compounds, but we will discuss few of them. And one class of the organic compound is the hydrocarbon. And if you remember the definition of the organic chemistry we started and discussed at the start of the this course. Organic chemistry is the chemistry of the organic molecules or the chemistry of the carbon compounds. That's why these are called the organic compounds, or simply you can call them the carbon compounds. So chemistry of the carbon compounds is called the organic chemistry. So basically there is the one element is necessity, and this is the carbon atom. And if you remember, I'm just explaining little bit the basic which we have already discussed in the previous classes. So if you see, this is the atomic number 6 and the mass number 12 of this carbon atom. And if you write the electronic configuration of the carbon atoms, and you will write there are the atomic number is 6, so it is having the 6 protons and the 6 electrons. And you, when you fill the electrons in the energy level, this is 1s2, and then the second principal quantum number, it is 2s2 and 2p2. This is the electronic configuration of the carbon. So here these outermost shell is very important, and you can identify the group by using these valence electrons. Valence electrons mean the electron present in the last shell. And if I can draw the electrons in a shell, and if I put this is the nucleus, this is the first shell, that is the K shell, and this should be the second shell, that is the L shell. And there are the 6 electrons. So 6 electrons I can just put over here. 2 electrons are in the first shell, and there are the the 4 electrons are in the second shells. That's what these are, the 1 2 and 3 4. So I'm going to just teach you. I have called the this valence shell. Valence shell is the shell, the outermost shell of any of the atom, and here it is the second shell, and in second shell there are the 4 electrons. So these 4 electrons are very important, and the maximum capacity of the bond formation of this carbon atom is the 4, because there are 4 unpaired electrons are there. And when unpaired electrons are from the carbon atom, so each of the unpaired electron can form a covalent bond, because the covalent bond is formed by the sharing of the electrons. So when each of the electron is shared with the any of the atoms, then maximum possibility of the bond formation is the 4, because there are 4 electrons are present. So I am starting with the very simple example. That means if there is a carbon compound, and it is having the only one carbon atom, then I will move to the 2 carbon atom, 3 4 and so on. And this nomenclature is very simple to remember, because we will use very some basic technique to remember all these organic compounds and their naming. Actually we will name them what would be the name of carbon atom if it is having only one, and what would be the name of the carbon atom if it is having the 2 carbon atoms and 3 carbon atoms and the so on. So here in the first thing we are just only considering the hydrocarbons. And carbons mean these the organic compounds only having the hydrogen and the carbons, and these are called the hydrocarbons, and it is indicated with the name carbons and the hydrogen. And today we will only discuss the organic molecules which are having the carbon and the hydrogen, and these are called the hydrocarbons. So let's start with the first basic uh, organic molecule, and this is the with the if carbon atom is only one, then again I'm going to draw a Lewis or the dot structure, which we you have already learned in one of the previous class. So as I have said, the maximum possibility of each carbon atom to form a covalent bond are four, because there are four electrons are present. Here I'm going to show these are the unpaired electron with the carbon, and these unpaired electron can be shared with the other element, and here we are just considering the hydrogen. And let's suppose this is the hydrogen atom, and there is the maximum possibility uh, uh, to have one carbon atom to have the hydrogen are four, because there are the four unpaired electrons. So I have just placed these are the hydrogen atoms, and one hydrogen atom is also having a one electrons. So one electron is coming from the carbon and one electron is coming from the hydrogen. So this is the sharing of the electrons. So with the sharing of electrons, that means this molecule will form a four covalent bonds, and you can draw a structure like this. That means this, you can place with the solid lines, and this is the carbon, hydrogen, and the this one is the last one, hydrogen. And this is the hydrocarbon, because this molecule is only having the carbon and the hydrogen, and the name of this one is called this is the ethane. So I am going to further elaborate how to name all these different molecules. So remember, over here, this is the name is ending with the "in". So actually, this the first part is important. That is the "it". When it, sorry, I have wrongly just to delete this one. This is the first one is the methane, and when there is the only one carbon atom is present, that means you can name with the meth, and "ane" is ending with, because this type of the carbon atoms are called the alkanes. So I am just discussing the first example, carbon atoms, and if I can further divide, let's mean there are the three types of the uh, hydrocarbons. The first one is the alkane, and the second one is the alkene, alkene, and the third one is the alkyne, alkyne. And here important over here is, this is the "ane", this is the "ene", this is the "ein". So alk is coming from the first name. So I will be moving further with the "ene" and the "ein", and all these are called the hydrocarbons: alkanes, alkene, and alkyne. So I, in the first phase, I am just discussing the what is the first kind of the hydrocarbon that is called the alkane, because this methane is ending with the ane. So you remember, if any molecule is ending with the name is ane, it belongs to the group of the hydrocarbon that is called the alkane. And if a molecule is ending with the name that is the ene, and then it belongs to the group of the hydrocarbon that is called the alkenes. And if it is ending with the ine, and that means it would belongs to the group of hydrocarbons that are called as alkyne. So I am moving to the second example. If we have the carbon atoms too, then what would be the structure? And first thing, you have to draw a dotted structure over here. There are the two carbons, so you can put two, and you may be put in the vertical or the horizontal, it is up to you. And each carbon is having the four valence electrons. This is important, you have to place the correctly the valence electrons over here. So I am so there are two carbon atoms, that means total number of the valence electrons are 8. So I am putting the electron over here. So this is the 2, then this is 4, 5, 6, 7. These are the 1, 2, 3, 4, 5, 6, 7, 8. So these are the 3, 3, 6, and 2, 8. So there are, I have correctly displayed over here. If there is the 2 carbon, then total number of valence electrons should be 8, and I have displayed over here. Now how many are the unpaired electron? There are the 6 unpaired electrons are there. So maximum capacity for this type of the molecule to form the single bond with the hydrogen are 6, because there are the 6 unpaired electrons are there. So I am putting the hydrogen over here. The next hydrogen, one unpaired electron is here, so you may put one hydrogen over here, one hydrogen over here, and one hydrogen is here. This is the here, here, and you have to put one hydrogen with each of the unpaired electrons. And maybe you can use a different symbol over here. So these are the uh, single bond with the hydrogen and the carbon, and these are the covalent bonds. And if you have a look over these molecules, so there are 1, 2, 3, 4, 5, 6, 7. So there are the 7 single bonds are there. And now you can draw a dotted structure: carbon, single bond, sorry, this is the carbon, single bond carbon. And then there are, each carbon is having the uh, one hydrogen bonded with the carbon. And this is the molecule. The second molecule, organic molecules, and which is having the two carbon atoms, and the name of this one is the, this is the ethane, ETH A N E. So this is the ethane. And remember, this molecule is again ending with the name A, and this belongs to the group of the hydrocarbons, which we call them the alkanes. And this is the name you should remember. If it is eth, that means this is belongs to the molecule which is having the two carbon atoms. And this is also, you can differentiate how to put the ane. If all are there the single bonds, that means these are the alkane. So the basic difference between the alkene and the alkyne is also one thing is it is ending with the name, and you can differentiate over here. If all the bond between the carbon is single bond, these are the, I'm going to show you the bonds, then this is called the alkane. And if there is any one of the double bond is present between the carbon and carbon, then it is called the alkene. And if it is the triple bond is present, then the molecules are called the alkane. So you can easily identify which class of the hydrocarbons is there with the help of the single, double, and the triple bond. So single bond with the alkane, double bond with the alkene, and the triple bond with the alkyne. And first molecule is methane, and it is meth is for the one carbon atom, and we use the H is for the two carbon atoms, and this will remain with the group of the hydrocarbon which we call them alkane. And remember, this is for the H is for the molecule which is having the two carbon atoms. So I am similarly, I am just as a practice, I am going with the let's suppose moving with the carbon atom which is having uh, the number of carbon atoms 3, the organic compound which is having 3 carbon atoms. And in a similar way you can just increase one carbon atom over here, and then to place the bond between the carbon. This is the, you have, even you can calculate at the end, it will satisfy whatever is the total number of the valence electron to 2 4. Why I am putting over 2? Because this is the carbon carbon bond, so each bond is sharing one of the electron from each of the carbon atoms. So that's why I have directly put over here the 2 electrons over here, then unpaired electrons, and these are the unpaired electron. And if you count, these are 1 2 3 4 5 6 7 8 9 10 11 12, and there are 3 carbon atoms, and each carbon atom is having the 4 electrons. So 4 threes are 12. So this is, maybe you can calculate first the electron and then display over here, or maybe you can use directly the methodology which I have used over here. You can place first the bond with the 2 electrons, and then place the unpaired electrons on each of the carbon atoms. So remember, there should not be more than 4 carbon atoms in each of the there should not be more than 4 electrons or the unpaired electrons uh, on each of the carbon atoms. So there are 3, 4, 5, 6, 7, 8 unpaired electrons are left. So there is the possibility to form the other bond with the hydrogen are like this. This is the hydrogen. You have to put each hydrogen shared with the unpaired electron with the carbon atoms. So these are the unpaired electron sharing with the hydrogen atoms. And each, remember, hydrogen is the first one molecule. So each hydrogen is having only the one electron. So I am placing the one electron over here. So this is the dotted structure. So you may write like in this form. This is the carbon, single bond carbon, and these are the hydrogen. Now you can show with the permanent bond with the solid lines, and these are the hydrogen. The hydrocarbon, because there is only hydrogen and the carbon atom are present. That's why this molecule is also called hydrocarbon. And the name of this molecule is the alkane. It belongs to the group of the hydrocarbon which we call them the alkane, because all there is the single bond are present between the carbon carbon. So that's why this type of the molecule is also called the alkane, and the name of this one is called the propane. Propane. This is the propane. Again, ane is ending because it belongs to the alkane, and this prop mean if there are three carbon atoms are present, then you should name with the prop. So uh, now I am just putting the name. You may say this is the counting for the organic molecules or the organic chemistry. So we have done the carbon atoms and their names. So if there are one carbon atoms, then we call them the meth, and it is ending with the ane if it is belong to the alkane. And similarly, if it is two, then you can name with the ETH, and ETH, and it is also ending with the name ethane. And with the three, so three is the prop, and ending with the ane, propane. And similarly, four will be the but, but, and ending with the ane, that means butane. And five is the pent, and ending with the same ane. I'm just going to up to the 10, and these will remain the same, and just we will use a different name, just the last name of all of these molecules. With the 6, if carbon atom are 6, then you can name with the hex, and ending with the ane, hexane. 7 is the heptane, and 8 is the octane. 9 is the nonane, and the 10 is the decay. Again, you must write along like this is the correct name. I'm just putting in a bracket just to differentiate what we are going to do in the next. So all these are the name of the hydrocarbons, uh, which belongs to the group of the hydrocarbons that are called the alkanes. Now I am moving to the second class of the hydrocarbons, and these are the alkenes. So now alk, remember here alkane and alkene, alk is the same. That means these molecules, these name would remain the same as given over here, but you just mention the ene instead of the ane. And now let's start with the first one molecules. And here I have already shown you actually alkene are the uh, the molecules which are having the carbon carbon double bonds, and alkane are the carbon carbon single bond. So the first basic molecule which is going to start with the nomenclature is the with two carbon atoms, because there is no possibility for a single carbon atom to have the double bonds. So alkene is starting with the ethene, the first molecule which belongs to the group of hydrocarbons, which is called the alkene, is called the ethene. So here just you have to replace all ene with the all ane with the alkene. So the first molecule over here, the name of this one would be the ethene. Ethene. remember. So this is ethene is indicating that this is the hydrocarbon which belongs to the alkene group. Okay, so now I am just putting the structure how it is. It will form the carbon-carbon double bond over here. So there are again the carbon atoms are two. So there are total valence electrons over here are the 8 because each electron is having the each atom is having the 4 valence electrons. So the first is you have to draw a skeleton. There are the two carbon atoms. So similar to the first one case, you have to put the two carbon atoms over here, and then each carbon is having a double bond, and there is the different explanation. I'm just going to explain. Let's suppose we will do with the same way which we have done with the ethane, like in a similar way, because there are the 8 valence electron, 4 and 4, there are 8 valence electron. This is the molecule of the alkane, and you can name it, this is the ethane. Now I'm going to move or to draw a skeleton structure for the ethene, because ethene is having carbon carbon double bond. So there is the possibility how the carbon carbon double bond is formed. There is the one unpaired electron is here, this is the one unpaired electron is here. So this unpaired electron may share with each other to form another bond, and when they share to each other, so what is the possibility? This is the carbon, again carbon, and now these are the uh, bonds which are already shared previously between the carbon carbon bond. And if they share like this, then there is the another two electrons are shared between the carbon carbon atoms, and what is left, these two unpaired electron left, these two unpaired electron left. Now there are 4 unpaired electrons are there, so maximum possibility to form a single bond of this carbon atom with the hydrogen is 2, and this carbon atom with the hydrogen is also 2. So maximum 4 hydrogen bonds can be formed with this ethene molecules. So I am putting the hydrogen. One hydrogen is here, one hydrogen is here, and one hydrogen is here, one hydrogen is here. So now you can put the, sorry, this is the electrons coming from the hydrogen. Now what would be the complete structure of this molecule? This is the carbon, double bond carbon, and now these are the hydrogen, hydrogen, and this is the one bond is hydrogen, one bond is the hydrogen. So maybe you can put in a straight line to show the hydrogen bonds with the carbon atoms. So now if this molecule is here, this molecule is also called hydrocarbon, because this molecule is only having the carbon and the hydrogen, and the name of this carbon or the group to whom this molecule is going to belong is called the alkenes, because there are at least one carbon carbon double bond is present, and that's why it belongs to the alkene. But the name of this molecule is the ethene, because ethene belong to the carbon atom. If there are two carbon atoms are present, then it is called the H, and that's why this is called the H. But ending with the ene due to the one double bond is present, so this molecule is called the ethene. And similarly, there would be the propene and the butene and the pentene. Let's suppose I am using another example. Let's suppose we will finish up with the pentene. So pentene mean there are the 5 carbon atoms are there, and you can form any the double bond between any of the carbon atoms over here. So I am just putting, finally you can do practice at home to put the daughter structure, and then you can name them accordingly what we have discussed, and it will follow the Lewis structure or the dot structure. This is the molecule, and the easiest way to remember each carbon must have the 4 bond, not less than 4, not more than 4. So this is the general or key concept to remember how you can finishing with the hydrocarbons or to draw a proper structure. So this is the molecules which is having the 5 carbon atoms, and the 1, 2, 3, 4, and the name of this structure or the molecule, organic molecule, is the pentene. Pent coming from the 5 carbon atoms, that is the pent, and ene is coming from the, because this pentene is having the carbon carbon double bond, it belongs to the group of the hydrocarbon that is called the alkene. That's why I'm ending with the pentene. So lastly, the third one, group of the hydrocarbons are called the alkyne. So I am just finishing because we have 3 minutes are left. If it is closed, the meeting is ended, then you may join again. So I think maybe because there is short time is left, so I'm going to wind up this topic over here.